I want you to take a moment and take everything we've been doing and put it together on these three problems. The first reads the square root of 72x to the 7th. The second one is the square root of 75 a to the 9th. And the third one is the square root of 98 a to the 7th b to the 5th. Go ahead and hit pause and see what you can do with these. All right, let's find out how you did. Well, when I see 72, I'm immediately thinking about that as being 8 times 9. Next to the 7th, well, I'm going to leave it as the square. It's x to the 6th times x. Some of you probably use the Orndorff method there, and that's fine. 8 goes a little bit further because it's 4 times 2. So I have 4 times 2 times 9. X to the 6th I'm going to think of as x cubed squared times x. So now let's deal with the square roots. I'm going to do things one part at a time. The square root of 4 is 2. The square root of 2, well, that's just the square root of 2. The square root of 9 is 3. The square root of x cubed squared is just x cubed. And the square root of x doesn't simplify, so it's just x. Just the square root of x, I'm sorry. When we clean this up by putting the numbers outside of the square root first, we would get 6 from 2 times 3, x cubed, times the square root of, I'm going to multiply the things inside the square root, 2 and x. If you didn't get it the first time, why don't you try the second one again, using this as a model. Go ahead and hit pause and give it a shot. All right, let's look at the second one now. Getting kind of messy here. 75 a to the 9th. Well, 75 is 25 times 3. I'm going to use the Orndorff method on a to the 9th. I like that way. I miss Richard. The square root of 25 is just 5. The square root of 3 doesn't go any further. And using the Orndorff method, 2 goes into 9 4 times, so that'd be a to the 4th, with 1 left over. So a to the 1st still inside. And we put it all together. The numbers outside, 5 a to the 4th times the square root of 3a. One more like this. The square root of 98 a to the 7th b to the 5th. Well, 98 is 49 times 2. I'm going to use the Orndorff method on these a's and b's. That's pretty much how I think about it almost every time. The square root of 49 is 7. The square root of 2. The square root of a to the 7th. Well, 2 goes into 7 3 times, so a cubed, with 1 left over, so a to the 1st. The square root of b to the 5th, 2 goes into 5 twice, so it'd be b squared times the square root of b. If I put this all together, the things outside would be 7 a cubed b squared times the square root of 2ab. A little bit of time left. Let's try something a little bit different, but I think you'll manage it. Let's look at an expression like 3 plus the square root of 32. Well, these things aren't like terms. I have a whole number, 3, and a square root number, the square root of 32. So I can't add them, but I can simplify the square root of 32, so I'm going to do that. 32, well, that's 16 times 2. And the square root of 16 is 4. So this would be 3 plus 4 times the square root of 2. And this is the best I can do. I can't combine these. These aren't like terms. This is a lot like having 3 plus 4x. They're just not like terms. They're not the kinds of things that I can combine. With that as an example, why don't you try this one? 5 plus the square root of 75. Hit pause and give it a shot. Let's see how you did. You know that 75 is 25 times 3. And the square root of 25 is 5, so this is 5 plus 5 square root of 3. And these aren't like terms. So, there's my final answer.